parameters. So just a frame transformation. Just for example, that transformation that I explained for the transforming from transformation between TRF and CRF are here. You can see this terrestrial transformation here, and here chapter 6 is geopotential. I explained everything on this document, so I can write over this document without any problem. So then let me go down and show you how this tide, solid tide, can affect the gravity field. So there's a formula here, and I show you. Yes, that's a formula. Let me, if I can annotate over this. Yeah, I can. So K is log number. It shows the log number shows the ratio of deformation with respect to the original shape of the Earth. And Gm is the gravitational parameters of the moon, and for the sun is J is 3. So Mj is the mass of the moon or sun, and Gm is the gravitational constant. M with the sign is the gravitational parameter of the Earth, and M is the mass of the Earth. Then equatorial radius of the Earth, Re, and Rj is the distance, geocentric distance of the moon or the sun. So it means that we need the distance between the sun and the Earth, and also sun and the moon and the Earth. So these log numbers are known. We already know that. Let me go a little bit up here. Need to change it to this. Okay, go up. Okay. So the position of this position of the moon and sun, the latitude, geocentric latitude of the position of moon and sun, and this is the longitude. So it means that we need the coordinates of the sun and moon as well. If we have that, we can simply put them inside this formula and compute how much these masses, I mean the moon and the sun, can affect the spherical harmonics of the Earth, which are this one. This is the correction, tidal correction to the sine coefficient, and this is the tidal correction to the cosine coefficient. Well, that's too simple, but we need to consider other things as well. Let me continue with you. So we need also other things to consider. We have some another correction which is applied to the degree 4, the spherical harmonics, as you see here, degree 4. And again, it depends on the position of the satellite, and it's very similar, but instead of K and M, we have K2 plus M. And the coefficients of the K2 are available here if you need it. This is the changes in the degree 4 coefficient produced for degree 2 type. So if I continue here, if you want to consider this K and M, if you consider the Earth elastic, the Earth is elastic here, then you will consider this love number. And when you consider the Earth unelastic, then the love number will be complex. It's a very complex number. And the real part is here and the imaginary part here. And this is the effect of J2 degree 2 coefficients on the fourth degree harmonics for both cases, for when the Earth is elastic or inelastic. So you can consider both of them. One of them, you consider the Earth is elastic or inelastic. And then we have other frequency dependent coefficients, corrections. Frequency dependent coefficients depend on the type of the tide. How do we do that? The contribution to the degree 2 is here. Is long periodic signal. So this is the real part of this term. So what does that mean? So I have K, I have H, A0, HF, and K. This is imaginary part, and this is the real part. Theta F I will explain later. So A0 is here, is a constant. Is a constant. And if you want to consider the contribution for the order 1 and order 2, you will use this here. So for 0 degree, 2, 0, this formula, and for M and 1 and 2, this formula. And in this formula, AM, you will use AM because A is 1 and 2 is not. It depends on M. And for eta 1 and eta 2, you will use minus these values simply. This is just a computational procedure. But this amplitude, which is HF and delta K and delta KF, we need a table to compute. This table is here. Let's see if I find a table here. Where is that? Yep. So it depends which component of the tidal component you want to consider. If you want to consider this tidal component, delta K, for the imaginary part is that, for the real part is that, and the amplitude for the image in phase means the real part, and this one is out of phase, is the imaginary part. You can take this value simply from this table. These are the non-tidal components. You just put them here. You just insert them in the formula. It depends on which type, which effect you want to consider to correct these terms. And here you will correct the second degree, this one, for this zonal term and for the other term. So you can compute the effect. This is just for the degree 2, and it's here I can explain how you can compute this theta F. Theta F can be computed by either this or this. So what are these? This delta G is in fact, we see, look at the definition simply here. Greenwich Mean Sidereal Time, GMST. Theta M is the GMST, There's a formula for computing that. Delaunay parameters is I will show you later what are the Delaunay parameters. Delaunay, it's called Delaunay parameters, and these are coefficients of the Delaunay parameters, and this is the order, M order. So based on this, you can compute theta f. So now I will show you where are these N and J parameters. N, J parameters are available in the same table that I showed you. Yeah, look at this table. You have 5 Delaunay parameters, which are these ones, and you have this coefficient. So NJs in the formula are here. So you select the tidal constituent, based on the tidal constituent, you will have the Delaunay coefficients, and you will compute theta f from Delaunay coefficient and GMST, Greenwich Mean Severe Time, and you have these values, phase and amplitude of each component. So there are two things, some steps that you consider for considering the effect of solid type. First, based on the position and the mass of the moon and sun, you will correct the coefficients, which is not frequency dependent. They are dependent on the position. And the second step, you will consider the position dependent. The frequency dependent. Then you will use this table plus the formula that are presented here for you for the 2M coefficients. And yeah, for the effect of this, you can compute the corrections. Of course, they have computed how to derive this phase element, but you will just need to learn how to apply. That would be fine. So you will use this table to consider the effect of other components, the frequency.